Welcome to April 10th LeetCode Challenge, baseball game. You're keeping score for a baseball game with strange rules. The game consists of several rounds where the scores of past rounds may affect future round scores. At the beginning of the game, you start with an empty record. You're given a list of strings ops where ops at index I is ith operation you may apply the record to the record, and one of the following. So you have an integer x is the record of a new score x. Plus operator, which is the record of a new score, is the sum of the previous two scores. It's guaranteed there's always the previous two scores. You have d, which is the record new score, double the previous score, guaranteed that there'll always be a previous score. C, invalid previous score, removing the record, is guaranteed that there'll always be a previous record. So return all the sum of the score on the record. So we have the following operations. Say that we have 5, right, and 2. So we basically, what we want to do is add 5 to the record, right? Now the record is 5. Add 2 to the record, and we add a C, which removes the previous record. So basically, it now is 5. If we have D, which doubles the previous record, which is 10. And then we have add operator, which adds previous two operators together, which equals 15. So now in our array we have 5, 10, 15, which is the sum of all the scores together equals to the sum of the records is 30. Similarly, here's another example. For example 2, we have 5 and negative 2, 4, C, D, and blah blah, the rest. So basically the first one we want to do is 5, add 5 to the record, right? So we have a record that's now 5. We have minus 2, add minus 2 to the record. We have a 5, negative 2. And then we have 4 to the record, so add 4 to the record. Now we have the C operator, which basically removes the previous record. So now we've removed 4, so therefore we have 5 and 2, negative 2. And we have basically D, which is double the previous input, which is basically 2 times negative 2, which is negative 4, so we add that to the record. We have 9, so we add 9 to the record. We have add, so we're adding 2 previous records together, which is going to be 9 and previous negative 4, which is 5. So now we add that on top of that. And we have another add operator, which has basically 9 and 5 together, which equals to 14. Sum the entire record together, that equals 27. If we have our operation of 1, add 1 to the record, therefore 1 is the only sum of the record left. So the length of operation is between 1 to 1,000. So the operation index I is C, D, and plus representing the string of negative. So we have basically we could add anything, basically ranging between basically negative 3 times 10 to the 4 to 3 times 10 to the 4. Operation add will always be 2 previous scores, and D and C and D operators will always be 1 previous score on the record. Oh, okay, that's a lot of explanation, but essentially you can see how every time we make we add another element or operation or character to our score operation array, we basically add one to the a list. So we're going to use a stack for this. So let's maintain the value of each valid round on a stack as we process the data. A stack is ideal because we're only dealing with operating that involves the last 2 or the last valid round. So we'll call it stack, and there's going to be a list. So for ops and operation, for operation and ops, or ops and ops, oh my god, what we want to do is do a bunch of if-else statements. So if the operation is equal to a plus sign, then what we want to do is append the stack. So what we want to do is stack.append. What do we want to append? We want to append the 2 previous stack elements, which is negative 1 plus stack of negative 2. Alright. Else if, let's just enter this down here actually, just make it look nicer. the operation is equal to the C, which is basically cancel the previous score, so be stack.pop, pop the last element, else if operation is equal to D, that means we add, basically append the last index stack, and we double that. Let's do star there. We basically double the last two elements and add that to the stack. Else, if it's not a plus sign, C or D, then it must be a number. And if it's a number only, we just append that number. The integer operation, because I notice how it's a string here, it needs to be a numeric value in order to be sum. And that's going to be the operation. At the end of all this, what you want to do, you want to return the sum of the stack. Alright, let's take a run at this. Looks good. Accepted. So yeah, this is a pretty nice one. Pretty much highlights the for loop, the if-else functions, and the stack as well. So it's a bunch of good stuff here. Time complexity is big O of n, or big O of linear time, where n is the length of the operations. So we parse through each element given the array once, and we do that in basically big O of constant time for each of them as well. So it would be big O of n for this, and then big O of constant, so big O of n for total time complexity. Space complexity is big O of n as well, because with the space used in our store or stack, right? Alright, and that's all. Have a great day, guys.